All right, hi guys. Today we're doing 10.2. We're going to continue looking at matrices, and today we're focusing on a couple other matrix operations, actually just one, and then we're going to be solving a little bit here for some missing entries. So in the previous video, we looked at just simple adding and subtracting of matrices and that they needed to have the same dimensions, and then you would just add or subtract corresponding elements or entries. To start today, we're going to look at multiplying, but we're only going to be looking at multiplying by a scalar. Now, you might not remember that word. Scalar is just a way of saying a regular number. So what I mean here is that we're multiplying one matrix by a number, and you can see in the examples below. If we were going to multiply multiple matrices together, like a matrix times a matrix, that's actually pretty complicated, and we'll look at that a little bit later on in another lesson and using our calculator. But multiplying by a scalar is actually really easy, and it's pretty much exactly like you would expect. So for example, in this first one, we're going to multiply this matrix by 4, and just like multiplying like a binomial or polynomial by a scalar or by a regular number, you're basically just going to distribute that multiplication. Okay, so this will become 4 times 3, 4 times negative 4, and 4 times 7. So multiply each entry by whatever the number out front is. So I'll simplify to get my final answer: 12, negative 16, and 28. And there's my answer. Part B, same idea. I'm multiplying by negative 2. So I'm going to multiply each entry by negative 2. Okay. So I'm doing 8 times negative 2. It doesn't matter what order you write your multiplication in. 3 times negative 2. Don't know why it keeps glitching like that. 4 times negative 2. And 0 times negative 2. Either way you want to write the order of the multiplying the two numbers, it's fine. And simplify again. Negative 16, negative 6, negative 8, 0 times negative 2, 0. And then in part C here, I'm multiplying this matrix by 0. And I know just like multiplying any number by 0, I get 0 as my answer. So if I multiply each entry by 0, that means each entry will just become 0. So I don't even need to write out the work for this one. And like we talked about in the last video, this is actually called a zero matrix. Gets a special name. It does have uses. We don't look too much at the usefulness of a zero matrix, but there are purposes to this, so that's why we're showing it here. And then our last one, we're going to combine a couple operations. So we'll multiply and add. And just like regular operations, we're going to follow our order of operations. So we'll need to multiply first. So for this first matrix, I'm going to multiply each entry by negative 5. So this becomes negative 25, negative 15, negative 40, and negative 10. And then I'm going to multiply the second matrix by positive 2, keep my addition in between them. So 2 times 4 becomes 8, 2 times 7, 14, then 18, then 20. And then lastly, I'll actually add those matrices together. So I'm going to add each individual entry, each corresponding entry. So negative 25 plus 8 becomes negative 17. Negative 15 plus 14 becomes negative 1. Negative 40 plus 18, negative 22. And negative 10 plus 20, positive 10 for my final answer. So our next topic today is solving for missing elements. So now we have an actual equation, right? We have an addition problem with an answer, so equal sign and then an answer. And this time we're missing some elements, okay? So we're going to be solving for those variables. So to do this, it's actually a lot easier than you might think. we're going to find the missing variable first. So I see an x and a y. Let's start with x. I want to highlight or circle that variable, and then I'm going to highlight whatever is in that corresponding entry or position from the other matrices. So in this matrix, that would be the bottom right corner, so the 1. The corresponding entry here is also in the bottom right corner, so also a 1. When I find those, I'm going to set them up as their own individual equation, because I know it's basically saying 1 plus 1 equals whatever should go here. So I can write that out very easy. 1 plus 1 equals x. So notice I'm keeping the operations exactly where they are. Simplify, 2 equals x, and I'm done with that part. Then I do the same thing. So I'm going to highlight the y, and then I'm going to find the entries in the same position, so top right, and I'm going to write them out. Notice I'm keeping the order the same, even though I started at the end for highlighting. You still want to start at the beginning when you write it out. So this becomes 6 plus 5 equals y. 6 plus 5 is 11 equals y, and I'm done. Pretty easy once you find those variables. Okay, so I'm going to actually jump down here to part C. Same idea, I'm going to start by finding a variable. So here's an x. Then I highlight everything in the same position. And now I'm going to write out my equation. This time it's subtraction, so x minus -2 equals 11. So I'm keeping the same operation and the negative from that entry. This becomes x plus 2 equals 11, solving an equation, so I'll subtract 2 from both sides. Therefore, x equals 9. One more here. I'm going to highlight. So looking for a variable, there's one. So I highlight everything in the same spot. And then I'll write it out. You could highlight or circle, whatever works better. So start at the beginning, 25 minus y equals 15. And we're solving this equation, so we'll subtract 25. Keep your negative y equals -10, 15 minus 25. To get rid of that negative, I can divide by -1. Therefore, y actually equals +10. Okay, so why don't you try B and D on your own. Start by finding the variable and writing out your equations and see if you can solve those too. All right, so you can check your answers here for B and D. Again, the highlighting or circling method I think helps a lot because it makes it a little bit easier to keep track of each entry. And so for part B, I got 0 equals y and 1 equals x. Part D, I got x equals 97 and y equals 5. Okay, so if you need to pause to look a little bit closer at my setup and my work, do so. On the next page here, there's a bunch of problems for you to try, 4 problems. So I want you to try those on your own. I'll leave these first 2 up, try these 2 first, and then you'll check your answers, and then I'll scroll down to 3 and 4 after that. All right, here are my answers for number 1 and number 2. So for number 1, I got x equals 5, y equals -2. And number 2, x equals 2 and y equals 8. Okay, so feel free to pause to look a little bit closer at my work for those as well. And then I have 3 and 4. So try 3 and 4, and then I'll show you the answers for those in a moment. All right, here are my answers for 3 and 4. Again, like always, pause so you can look closer at my work. For number 3, we actually had 3 variables, so make sure you have the right positions for all 3 equations. So x equals -3, y equals -14, and z equals 10. And then number 4, we were multiplying like we did at the beginning of the lesson. So you can look at my final matrices there in the black rectangles.